Hello everyone, our today's session is about statistical errors. You are seeing a nice picture here, and I'm sure we can all agree that sometimes statistical errors can make us feel just as puzzled as this doctor. But don't worry, we'll break it down in a fun and simple way so you can fully understand how type 1 and type 2 errors affect our day-to-day clinical decisions. By the end of this session, you will know exactly how these concepts relate to your medical practice, and trust me, it's going to be fun. Let me start with a simple question. My question is, have you ever gotten a test result that felt wrong? Okay? Has there been a time when you received a test result but your gut told you something was wrong? Maybe the result was a bit confusing. It said everything was fine, but you felt something is missing. Those situations happen because of what we call type 1 error and type 2 error. Let's dive into understanding what they are and how can minimize them in our clinical practice. Can you tell me why should we care about errors? Why should we care about errors? These errors aren't just statistics, they impact real people. Imagine making an important decision based on a false positive result or a missing life-changing diagnosis because of a false negative. Both of these scenarios are extremely serious in medical practice. So, our ability to understand these errors and prevent them is essential for delivering the best care. Delivering the best care to our patients. Whether it's an unnecessary treatment from a type 1 error or a misdiagnosis from a type 2 error, both situations can deeply affect our patient outcome. Okay? Clear it? Next is, to understand errors, we first need to know the basics of hypothesis testing. There are two main hypotheses. One is null hypothesis, another is alternative hypothesis. So the null hypothesis is the default assumption that nothing is happening or there is no effect. That means there is no effect. And the alternative is what we are trying to prove, suggesting that something is happening or there is an effect, has an effect. So null hypothesis means there is no effect. Alternative hypothesis means there has an effect. Okay? Clear it? So when we run tests, our goal is to gather evidence to either reject the null hypothesis or fail to reject it. Errors can occur when our decision doesn't match the actual truth, leading to type 1 or type 2 errors. Okay. So, what is type 1 errors? What is type 1 errors? So, let's start with type 1 errors. These error type 1 errors. This error happens when we reject the null hypothesis. We reject the null hypothesis. What does it mean? This means we think something is happening when it's not. Okay? This means something is happening when it's not. Look at this image. The image on this slide is a perfect illustration. A doctor tells a male patient, you are pregnant. That's clearly not possible. It's a type 1 error. While there is a funny example in real life, it can lead to serious consequences such as diagnosing a patient with a disease they don't have. Clear it? Now let's look at type 2 errors. This happens when we fail to reject. We fail to reject null hypothesis. We fail to reject null hypothesis. This means we miss something important. Okay? Look at this picture. The doctor tells a very obviously pregnant woman, you are not pregnant. That's a type 2 error. Missing something, okay? Missing something that is clearly there. In real life, this could mean failing to diagnose a condition that needs immediate treatment. I repeat, failing to diagnose a condition that needs immediate treatment. So, why do these errors matter? I am just trying to correlate it with our medical practice. So, my next question is, why do these errors matter? A type 1 error can lead to overtreatment. For example, a patient might be wrongly diagnosed here. A patient might be wrongly diagnosed with a condition and undergo unnecessary tests, medications, or even surgeries. And in type 2 error can result in undertreatment. This is overtreatment due to wrong diagnosis, and this is undertreatment due to missing diagnosis. Here, a patient's real condition might go unnoticed, leading to delayed care and potentially worse outcomes. So in our field, both false positives and false negatives can have serious consequences. So it's crucial to minimize them as much as possible. Am I clear now? Okay, let's summarize it. Here the null hypothesis is the default assumption. This is patient is not pregnant. This is null hypothesis. We know that null hypothesis means there is no effect. Here the test result says you are pregnant, but the patient cannot be pregnant. So what happened here? The test rejected the null hypothesis even though it was actually true. So we rejected the null hypothesis. This means the test incorrectly said the patient is pregnant, which is false positive. Look at the image number 2. We know the null hypothesis and the default assumption is patient is not pregnant, but test result here is you are not pregnant. Okay, but the patient is visibly pregnant. What happened here? The test failed to reject the null hypothesis even though the null hypothesis was actually false. The null hypothesis is patient is not pregnant, and the test result says you are not pregnant, but in reality the patient is pregnant. So test failed to reject the null hypothesis. We should reject the null hypothesis because the patient is pregnant and the test results are wrong, but we fail to reject the null hypothesis and we accept it, and the result is false negative. Clear? These both error, type 1 and type 2 errors, involve the same null hypothesis. The patient is not pregnant. This is our null hypothesis. The difference lies in whether the null hypothesis was wrongly rejected, that is type 1 error, or wrongly accepted, that is type 2 error. As we did the errors, so we have to know how can we reduce errors. The good news is that there are ways to reduce these errors. One is to reduce type 1 errors, we can increase the specificity of our test. This ensures that we are not over-diagnosing or falsely identifying conditions. To reduce type 2 errors, we can enhance the sensitivity. We can enhance the sensitivity of our test. This ensures that we are catching real cases and not missing important diagnosis. So the balancing sensitivity and specificity is key to making accurate clinical decisions. It's all about getting the right balance to make sure we are neither over-treating nor under-treating. So thank you so much everyone. I hope this session helped clarify the concepts of type 1 and type 2 errors. And thank you again.